take you back to the early 1990s, sleepy little laboratory in Parma, Italy, and scientists had a MRI brain scanning machine on a macaque monkey as the macaque monkey was trying to open up a nut. They wanted to see how the neurons would light up. So the monkey's trying to open up the nut, the neurons light up, and just by serendipity, and this is how science sometimes happens, a human being walked into the laboratory, I don't know if it was by mistake, and he was hungry, he saw the nuts and opened up one of the nuts and tried to crack it open. The macaque monkey was totally shocked because who was this invader in his laboratory? And he didn't move. He just gazed at this human trying to open up the nut, just like he had done a few seconds earlier. And then the scientist looked on the MRI brain scanner. The same exact neurons were lighting up when he observed the human being opening the nut as when the monkey opened the nut. And the scientists had not a clue as to what this was. They thought the MRI machine had broken. They then began to put MRI brain scanning machines on other primates, especially chimpanzees with our big neocortex. Then they went to humans, and what they found over and over again is something called mirror neurons. And that is that we are apparently soft-wired, some of the primates, all humans. We suspect elephants. We're not sure about dolphins and dogs. We've just begun. But all humans are soft-wired with mirror neurons so that if I'm observing you, your anger, your frustration, your sense of rejection, your joy, whatever it is, and I can feel what you're doing, the same neurons will light up in me as if I'm having that experience myself. Now, this isn't all that unusual. We know if a spider goes up someone's arm and I'm observing it going up your arm, I'm going to get a creepy feeling. We take this for granted, but we are actually soft-wired to actually experience another's plight as if we are experiencing ourselves. But mirror neurons are just the beginning of a whole range of research going on in neuropsychology and brain research and in child development that suggests that we are actually soft-wired, not for aggression and violence and self-interest and utilitarianism, that we are actually soft-wired for sociability, attachment, as John Bowlby might have said, affection, companionship, and that the first drive is the drive to actually belong. It's an empathic drive.
Among the purported functions of mirror neurons are action simulation, as I said in the beginning of my talk, and of course theory of mind, and almost certainly involved in imitation, because imitation of a skill requires you to adopt the vantage point of the other person performing the skill who you're imitating. Maybe pretend play, which Simon here talked about earlier, empathy for touch, pain, and emotion, and possibly language, although that's controversial. So I'm going to talk about all of these. Well, not talk about them, just mention them. When Giacomo Rizzolatti was giving his talk on mirror neurons about 10 years ago, Eric Altschuler, a postdoc of mine, and I were sitting in the audience, and we nearly jumped off our seats saying, my God, this is a almost perfect match between what you see here, the symptoms you see in children with autistic traits. So we said, well, this is almost too good to be true because it's such a precise match, and there's no other neurological syndrome where you see such a combination of traits. Now I want to emphasize here that arguing that mirror neuron system is involved in some of these symptoms is not to imply that there are no other etiologies for autistic signs and symptoms. In fact, you heard some from possibilities from Cochrane, and you heard some from Simon Baron-Cohen. So the idea that mirror neuron system might be involved complements these other theories. It doesn't necessarily contradict them. So based on the striking similarities, we suggested that maybe there's an alteration in the mirror neuron system in ASD, in some autistic children. Not necessarily permanent deficits, because let's take a look at the evidence for this theory. And it turns out, by the way, we were not the first to propose these deficits. In fact, Giacomo himself had hinted at the possibility, and others have. But I think we were the first to provide experimental evidence. We, meaning Eric Altschuler, a postdoc in my lab, working in Dr. Pineda's lab, looked at mu wave suppression, EEG, a component of EEG, human EEG, which is seen when a person performs an action. There's mu wave suppression when I perform an action like grabbing something or pulling something. And intriguingly, the same suppression of mu wave occurs when I watch you performing an action. In autistic children, what we found was the mu wave suppression occurs when the child moves and performs an action, but not when the child watches somebody else performing the action, suggesting to us very strongly that we are on the right track in postulating a change in the mirror neuron system. And since then, there's been several lines of evidence. I'm showing you all the papers which support using FMR and mu wave suppression. There are about slightly less than a dozen studies showing that mirror neuron system is. A study by Casanova, which came out in 2010, and more recently my former postdoc, Lindsay Oberman, has been pursuing this at Harvard, using TMS, the mirror neuron system, transcranial magnetic stimulation, showing some relief of symptoms of autism. So there's 3 studies, in fact. Endicott in Australia, Casanova, I don't know where he is, his group, and then Lindsay Oberman at Harvard, showing that you can reverse many of the symptoms of autism. So at the very least, the mirror neuron theory has inspired new treatments, even if the theory turns out to be wrong, okay? Inspired new treatments and treatment options. Now, Pineda and his collaborators, including Darko, a graduate student, have started using biofeedback to enhance mu wave suppression in these. So I want to go back.
It's a test to see if elephants can think about the minds of other elephants. This green table is holding 2 bowls of tasty elephant snacks.
A single rope is thread through and around the table, the idea being that it's kind of like a pulley system. So if one end is picked up by one elephant and pulled, the other end becomes unthreaded from the table and the table doesn't move.
The elephant has to learn to wait for his partner before he pulls the rope. Once his partner arrives, they both know to coordinate that pulling to get the food together.
They have to have some basic understanding that if the partner is not there and the partner is not pulling, the table doesn't work.
Joshua's experiment suggests that elephants can think about what other elephants are thinking. They may have at least the basic mental equipment for religion. This could explain a profound behavior that has been observed in the wild.